Hello there, and welcome to the lecture on DC Review, Part 1. We're going to start today with a review of a few concepts. First off, we have to get a couple of things down, make sure we really understand them. Let's start with some terms. The first is current. I know electricity seems to be kind of a mystery, but the fact is it actually is a real thing. It's a real flow of real electrons through a conductor. Electrons make up part of an atom. A conductor is just basically anything that is conducting electricity. In this case, there's heat conductors, light conductors, sound conductors. We're talking electrical conductors. So current, keeping it simple, is the flow of, those are real physical things, electrons, and it flows through a conductor, typically what we are all most familiar with, a copper wire. It's stated in amps, and the symbol is I. Current, the electrons, that's what gets everything done, the stuff that we care about, turns the lights on, makes popcorn in the microwave, etc. Voltage. Voltage is the force. It's an electromotive force, and it's pushing the electrons. You can think of it as the pressure behind the electrons. It is not actually pressure, don't get confused there, but it is like pressure pushing water. It's pressure pushing electrons. It's stated in volts, and you will see the symbol as E or V. I use E all the time. It's just the convention I've always used. The E stands for electromotive force. Next is resistance. Resistance is the force or the physical property of a substance which opposes current. It's stated in ohms. The symbol is omega, the ohm symbol. Now, something to keep in mind is all things have a physical property opposing current, other than superconductors, which scientists are trying to make. So even our copper wires, and even when we do our schematics on the board and we do our solving for problems, we count that resistance as zero. There is some resistance. There is a little bit of a physical property opposing the current flow. So we have current, that's the actual number of electrons flowing past a point, stated in amps. Voltage, the force pushing them, stated in volts, E. And resistance, the force opposing the flow. So now let's get into Ohm's law. Ohm's law, like all physical laws, isn't a rule, it's describing. And it describes the relationship or interaction, if you prefer, between voltage, current, and resistance. Now, correctly stated, Ohm's law states electric current, I, is directly proportional to the electromotive force and inversely proportional to the resistance. So to correctly state Ohm's law shorthand, it would be I equals E over R. You will often see this, E equals I times R, and these are algebraically the same. But this is the more precise way to think of it. Some symbols. We can't see electricity. We often have to use wiring diagrams and schematics, things like that. And we use symbols on the diagrams, on the schematics, to represent physical properties. There's all kinds of, or physical components, excuse me. There's all kinds of symbols, and unfortunately, there is not actually a universal standard for the symbols. So these are just some basic ones. There'll be some slight variations. This here is a battery. This consists of 3 cells. Right here, this is one cell of a battery, another cell, and a third cell. So this would be a 3-cell battery. This is a resistor. This is the symbol of something that's resisting current flow. We actually have electronic components, little pieces of carbon, because there's reasons in circuits we want to resist the flow, and we'll get into that in the next lesson. Or We can also, you can think of any kind of electrical load, right? Like if we were drawing a wiring diagram of my kitchen, I could think of my microwave as a resistor. It's resisting the current flow. It is, if I was looking at the current all throughout my house, I could just draw that as a resistor. I don't need a schematic of a microwave. This is a variable resistor. Dimmer lamps are variable resistors. It's got the arrow on top of the resistor, kind of symbolizing we can change it. This is an inductor, a coil, and these have more application with AC circuits than DC, but sometimes they are used in DC circuits. This is a capacitor. Think of it as an electron bucket. This will actually blocks DC. This is kind of a universal symbol here. This could be a motor, a generator. Sometimes you'll see it like this, and then it's a voltmeter. That M would be in the middle, or maybe the G for the generator, etc., etc. Here we have a fuse, and here we have a circuit breaker. A circuit breaker and a fuse perform the same function. There's something that opens up when the current gets to be too great. It's to protect things from burning up. A fuse is a one-time use item, of course. A circuit breaker is resettable. The last thing I want to cover in this little brief lesson is metric units. Metric units are really important to understand, and the metric numbering system, remember that, because volts, amps, and ohms are metric units. And we're going to use the as we're doing our math and doing our conversions using meters, all of this, we need to understand the metric way of doing things. And the metric way is, here's the base of whatever it is, whether we're talking volts or meters or liters, it doesn't matter, here's the base. And then kilo, make this a little easier to see, right there, has the prefix K, that's 1,000 times the base. Mega is a capital M, that's 1,000,000 times the base. And giga is 1,000,000,000. Going the other way, smaller, this is a small m, this is 1,000th. Then micro is by this funny U, which is 1,000,000th, and just a little n. So how do we solve these things? So let's take a look at, if I said I have 1,000 volts, and I want to know how many kilovolts. So if I had 1,000 volts, then I have just 1 kilovolt. Do you see that? What about in the case where I have 35 milliamps? So I have 35 milliamps, 0 point, means I have 0.03, can't draw. 35 amps. 35 milliamps, 0.35 amps. What if I said I had 4,700,000 ohms? So there's 4,700,000 ohms. Well, that's 4.7 mega ohms. So I'll give a little homework that has more of this metric system review, but this is just a quick overview of the terminology and just a refresher of some of the DC review terms. Thank you for tuning in.